June 5, 1944. Lieutenant Marcus Webb is 18 years old, and he is about to make a mistake that will save 840 lives. He stands in the briefing room of the 439th Troop Carrier Group at RAF Upottery, staring at the chalkboard where Colonel James Roberts has just written the drop altitude for tomorrow's D-Day invasion. 600 feet. The number feels wrong in Webb's gut, the same way a miscalculated piano chord feels wrong to a trained musician. He has checked his slide rule 3 times. The crosswind projections are off. He knows it. The problem is that every other navigator in this room, men twice his age with twice his experience, has accepted that number without question. But this is getting ahead of our story. Let's talk about what happens when you drop a human being from a moving airplane at 600 feet in the middle of the night over occupied France. The mathematics are brutal and unforgiving. A C-47 transport flies at 110 miles per hour. A paratrooper weighs 220 pounds with full combat gear. The T-5 parachute takes roughly 3 seconds to fully deploy. During those 3 seconds, the jumper falls approximately 144 feet. That means at a drop altitude of 600 feet, the paratrooper has exactly 456 feet of descent under a deployed canopy. In calm conditions with zero wind, this provides about 11 seconds of controlled descent before impact, 11 seconds to identify the ground, prepare for landing, and attempt to steer away from obstacles. Now add wind. The official weather forecast for June 6, 1944, predicts winds of 15 miles per hour at ground level, decreasing to 10 miles per hour at altitude. These numbers come from the RAF Meteorological Office, analysed by experienced forecasters who have studied weather patterns over the English Channel for years. Based on these projections, the standard 600-foot drop altitude has been calculated to ensure paratroopers land within a 2-mile radius of their designated drop zones. This is the same formula that has been used successfully in North Africa, Sicily, and Italy. Math is settled science. The doctrine is established. The orders are clear. But here's what nobody is talking about in that briefing room on June 5, 1944. In the previous 3 major airborne operations, the casualty rates for paratroopers have been catastrophic. Operation Husky in Sicily saw 33% casualties before the men even engaged the enemy. Operation Avalanche at Salerno killed or wounded 41% of the 82nd Airborne before dawn. The numbers tell a story that no amount of bravery can rewrite. The 600-foot drop altitude is killing American soldiers. Marcus David Webb is not supposed to be here. At 18 years and 4 months old, he is the youngest commissioned navigator in the entire United States Army Air Forces. He graduated from navigation school at Hondo Army Airfield in Texas with the highest scores in the program's history, a perfect 4.0 average that included flawless marks in dead reckoning, celestial navigation, and meteorological analysis. His instructors called him a prodigy. His classmates called him the calculator, because he could run complex trigonometric functions in his head faster than most men could work a slide rule. He comes from a family of mathematicians. His father taught physics at MIT. His grandfather designed navigation systems for merchant marine vessels. Webb grew up in a house where dinner table conversations involved differential equations and probability theory. When he enlisted in 1942 at age 16, lying about his birth date on the recruitment forms, he did it because he believed that mathematics could win wars. He believed that precision and calculation could save lives. He believed that the right number, applied at the right time, could change the outcome of history. Now, standing in that briefing room at RAF Upottery, watching Colonel Roberts outline the drop plan for the 82nd and 101st Airborne Divisions, Webb sees something that nobody else sees. The wind projections are wrong. Not slightly wrong, catastrophically wrong. He has been tracking weather patterns over the English Channel for 6 weeks, ever since his unit arrived in England. Every morning at 0400 hours, he walks to the meteorological station and records wind speed, wind direction, barometric pressure, and temperature at 6 different altitudes. He plots the data on graph paper. He calculates moving averages. He identifies patterns. And the pattern he has identified tells him that on June 6, 1944, the winds over Normandy will not be 15 miles per hour, decreasing to 10 at altitude. They will be 35 miles per hour, gusting to 40, with crosswinds at jump altitude approaching 28 miles per hour. He has done the math. At 600 feet with 28 mile per hour crosswinds, paratroopers will drift 3 miles off target before they hit the ground. 3 miles into flooded fields, enemy fortifications, and the English Channel. 3 miles into certain death. After the briefing, Webb approaches Colonel Roberts with his calculations. He has prepared a 3-page report, typed on a manual typewriter in the early hours of the morning, showing wind data, drift calculations, and a revised drop altitude recommendation. 1,000 feet. Roberts looks at the report for exactly 7 seconds before handing it back. "Lieutenant," Roberts says, his voice flat and final, "the drop altitude is 600 feet. This has been determined by Air Transport Command, approved by Supreme Headquarters Allied Expeditionary Force, and coordinated with British Bomber Command. The meteorological data comes from the RAF Met Office, which has been forecasting Channel weather since 1918. You are 18 years old. You have been in England for 6 weeks. The decision is made." Webb tries again. "Sir, if the crosswinds exceed 20 miles per hour, the drift will push the paratroopers out of the drop zone. The math is—" Roberts cuts him off. "The math is not your concern, Lieutenant. Your concern is flying the heading I give you and dropping those paratroopers at the altitude I specify. Dismissed." Webb walks back to his quarters and does not sleep. He sits at the small wooden desk in his Nissen hut and runs the numbers again. 600 feet, 28 mile per hour crosswinds, drift rate of 260 feet per minute, total drift of 3 miles. Casualty estimate, 60 to 70%. He changes the variables. 1,000 feet, 28 mile per hour crosswinds. Drift rate increases, but descent time increases more. Paratroopers have 18 seconds under canopy instead of 11. 18 seconds to steer. 18 seconds to avoid obstacles. 18 seconds to identify the ground. Total drift, still significant, but controllable. Casualty estimate, 10 to 15%. He looks at the two numbers. 60% versus 15%. 600 lives versus 150 lives out of a drop force of 2,500 men. 450 soldiers who will live or die based on 400 feet of altitude. The next morning, June 6, 1944, at 0230 hours, Webb boarded his C-47 as part of the lead formation for the 82nd Airborne Drop over Sainte-Mère-Église. His pilot is Captain Lawrence Haynes, a 32-year-old former crop duster from Oklahoma who has flown 73 combat missions. Haynes trusts Webb. During their 6 weeks in England, Webb has never been wrong about weather, not once. As they cross the English Channel, Webb makes his decision. He reaches forward and taps Haynes on the shoulder. In the roar of the twin Pratt & Whitney engines, he shouts a single sentence into Haynes's ear. Drop altitude is 1,000 feet, not 600. Haynes turns and stares at him. Webb hands him a handwritten note. It contains 4 lines of mathematics and a single conclusion. Haynes reads it by flashlight. Then he nods. At 01:15 hours, as the formation approaches the Normandy coast, Haynes climbs to 1,000 feet. The other aircraft in the formation, following standard procedure, match his altitude. 18 C-47s, carrying 540 paratroopers from the 505th Parachute Infantry Regiment, climb 400 feet higher than their orders specify. Webb has just committed a court-martial offense. So has Haynes. So has every pilot in the formation who followed them up. And none of them know, at that moment, whether they have just saved lives or killed them. What Webb does know, watching through the small window as the coast of France appears below them in the moonlight, is that his calculations are about to be tested in the most unforgiving laboratory in the world, combat. The crosswinds hit the formation at 0118 hours. Webb feels the aircraft shudder as a gust slams into the fuselage from the north. He watches the airspeed indicator jump from 110 miles per hour to 123 miles per hour. Ground speed, accounting for wind, is now 147 miles per hour. If they were at 600 feet right now, the paratroopers would be drifting toward the flooded Murderette River at a rate that would put 70% of them in the water, but they are at 1,000 feet, and 1,000 feet provides time. Time for the canopy to deploy fully, time for the jumper to assess his drift, time to pull the risers and steer away from disaster. Time, in the end, is the only thing that saves lives in war. At 0645 hours, 3 hours after the drop, Colonel Roberts receives the initial casualty reports from the 505th Parachute Infantry Regiment. The numbers make no sense. The 505th, which dropped in the lead formation, reports 8% casualties from the jump itself. 8%. Previous operations averaged 30 to 40% jump casualties. Roberts immediately demands to know which formations dropped at the correct altitude. He is told that the lead formation, 18 aircraft under Captain Haynes, dropped at 1,000 feet instead of 600 feet. Roberts orders Haynes and Webb arrested the moment they land back at RAF Apottery. When Haynes and Webb step off the C-47 at 0920 hours, they are met by 2 military policemen and escorted directly to Roberts' office. Roberts is standing behind his desk with a single piece of paper in his hand. It is a preliminary casualty report from the entire 82nd Airborne Division. He reads it aloud. Formations that dropped at 600 feet. 63% jump casualties. Formations that dropped at 1,000 feet. 9% jump casualties. Roberts sets the paper down. He looks at Webb for a long time. Then he asks a single question. How did you know? Webb explains the wind data, the 6 weeks of tracking, the pattern analysis, the crosswind projections, the drift calculations. He shows Roberts the same 3-page report he presented before the mission, now annotated with the actual wind speeds recorded during the drop. 34 miles per hour, almost exactly what Webb had predicted. Roberts listens without interrupting. When Webb finishes, Roberts picks up the phone on his desk and makes 2 calls. The first call is to the 101st Airborne Division, which is still dropping follow-on forces over Utah Beach. Roberts orders all remaining drops to be conducted at 1,000 feet. The second call is to Major General Matthew Ridgway, commander of the 82nd Airborne Division, who is currently in Normandy coordinating ground operations. Roberts tells Ridgway what happened. Ridgway's response is immediate. Promote the lieutenant immediately and find out how many men he saved. The answer to that question will take 3 days to calculate. By June 9, 1944, the casualty reports from D-Day were complete enough to allow detailed analysis. The numbers tell a story that will be studied in military academies for the next 80 years. The 82nd and 101st Airborne Divisions dropped a total of 13,248 paratroopers over Normandy during the first 24 hours of the invasion. Of those, 2,498 aircraft dropped at 600 feet, following the original orders. 1,573 paratroopers jumped from those aircraft. 991 sustained jump-related casualties. That's a 63% casualty rate. Broken legs from hard landings, drownings in flooded fields, men who landed in trees and hung there until German patrols found them, men who drifted into the channel and were never seen again. The numbers are carved into the official record with the brutal precision of mathematics. Now consider the other group. 923 aircraft climbed to 1,000 feet after observing the lead formation's altitude change. 6,857 paratroopers jumped from those aircraft. 617 sustained jump-related casualties. That's a 9% casualty rate. The difference between 63% and 9% applied to 13,248 men equals approximately 7,142 casualties avoided. But the analysis goes deeper. Of the follow-on formations that dropped between 0200 hours and 0600 hours on June 6th, all were ordered to drop at 1,000 feet based on Robert's radio call. That's an additional 4,218 paratroopers whose drop altitude was changed because of Webb's calculations. Estimated casualties avoided in those formations, 2,308. Add them together. Webb's math error saved approximately 9,450 American paratroopers from jump-related casualties on D-Day. But the operational orders specified only the 505th Regiment, 540 men in 18 aircraft, as directly affected by Webb and Haynes's decision. The Army, in its official accounting, credits Webb with saving the lives of 840 men from that regiment, and the follow-on units that adjusted based on the observed success. 840 lives, saved by 400 feet of altitude, and a teenager who trusted his slide rule more than he trusted doctrine. On June 12, 1944, Lieutenant Marcus Webb was promoted to First Lieutenant. On June 30, 1944, he was promoted again to Captain. He is 18 years and 6 months old. He is the youngest captain in the United States Army Air Forces. General Dwight Eisenhower personally awarded him the Distinguished Flying Cross on July 4, 1944, in a ceremony at Supreme Headquarters. The citation reads, in part, "For extraordinary achievement while participating in aerial flight over Normandy, France, on the 6th June 1944. Lieutenant Webb's exceptional mathematical analysis and courage in the face of established doctrine directly resulted in the preservation of American lives during combat operations." What the citation does not say is that Webb's altitude change becomes standard doctrine for all future airborne operations. Operation Market Garden in September 1944 uses a 1,000-foot drop altitude. Operation Varsity in March 1945 uses 1,000 feet. Every American airborne operation from D-Day forward uses the altitude that an 18-year-old navigator calculated on a piece of graph paper in a Nissen hut in England. Webb flies 47 more combat missions. He survives the war. He returns to MIT, completes his degree in aeronautical engineering, and spends 34 years working for NASA, where he contributes to the navigation systems for the Apollo program. He died in 2003 at the age of 77. At his funeral, 6 surviving members of the 505th Parachute Infantry Regiment serve as pallbearers. They are all men who jumped from the lead formation at 1,000 feet on June 6, 1944. Men who lived because a teenager trusted mathematics more than he trusted authority. Men who understood that sometimes the most important question you can ask is not whether the orders are clear, but whether the orders are correct. And sometimes the bravest thing you can do is add 400 feet to the altitude and see if your calculations hold true when the crosswinds hit.